Good afternoon. This is a video to help you create a cheat sheet for skill test 3, which will cover new skills including complex numbers, factoring, solving quadratics, graphing polynomials, and dividing polynomials. We're going to start with factoring. I want you to remember two things out of factoring. One is greatest common factor, factoring. For example, if I have 18x squared plus 27x, I can take out a common factor of 18 and 27, which is 9 and x. 9x, and I take 18x squared and divide it by 9x. And take 27x and divide it by 9x. And I get 9x times 2x plus 3. And that I can now multiply that out to make sure I get that. The other kind of factoring I want you to remember is trinomial factoring. This is ax squared plus bx plus c. I'm going to write down the process and then write down an example. So first of all, the process is multiply a times c, first and last coefficient. Second, find factors of a times c that add to b, the middle term, middle coefficient. Then split middle term into the factors of b. And then finally factor by grouping. Okay, let me give you an example of that. We will use 4x squared. Let's do plus 6y squared, and then finally minus 11xy. Okay, I'm going to go through this process and put out the last step early here, which is FOIL to check. And I'll do that as well, FOIL to check. Okay, so first step says multiply a times c, which is 4 times 6. That gives you 24. Then find the factors of 24 that add up to negative 11. And if you have to write bunches down to get there, that's fine, but I have no, that's negative 3 and negative 8. Then split up the middle term into the factors of b, that negative 3 and negative 8. So in other words, make it 4x squared minus 3xy minus 8xy. They have to both be xy, otherwise you won't get 11xy when you add them up, plus 6y squared. There we go. That's splitting up the middle term. That was step 3. Finally, factor by grouping means take the greatest common factor of the first part, take the greatest common factor of the second part. And in this case, I can just take an x out of the first part. I get 4x minus 3y. The second part, I can take looks like a 2, a negative 2, and a y. And I will get 4x minus 3y. At this point, if these are not the same, you either did this factoring step wrong, or you picked the wrong factors. So check that. Check both of those. If these are not the same, don't force them to be the same. It means you made a mistake if they're not. Okay, so now put them together, group them together, and you get x minus 2y over 4 times 4x minus 3y. And there's my answer. Now I can check that by foiling. X times 4x is 4x squared. Outer minus 3y times x is minus 3xy. Inner minus 8xy. And finally last, minus 2y times minus 3y is plus 6y squared. And notice that is the same as that line. And then I can put those together. 4x squared minus 11xy plus 6y squared. There we go. So again, two types of factoring to remember for factoring. One is greatest common factor, and the other is trinomial. And if you need more examples of this, feel free to put those down also. Okay, next, complex numbers. Okay, first of all, a definition. I is the square root of negative 1, or another way of saying that is I squared is negative 1. And what I did is I went through and showed you how to add, subtract, multiply, and divide. So I'll do the same thing here. Add, you just add like terms. So for example, I have 4i plus 3 minus I plus 2i. They can group these, plus 5. I can just add the 4i and the 1i there and get 5i. Subtract an I there, get 4i, 6i. So I get 6i. And then for the real part, I get 3 plus 5 or 8. There we go. So that's pretty straightforward. Just add like terms. Add the complex part, add the real part separately. Okay, multiply. Multiply, you FOIL and let I squared equal -1. So let me give you an example of that. 2 plus I times 3 minus I. So FOIL, 2 times 3 is 6. Outer, minus I times 2 is minus 2I. Inner, 3 times I is plus 3I. And finally last, minus I squared. This now you make -1. So this becomes +1. Or in other words, this becomes 7. And you put these two together in terms and get plus I. And that is multiplication. Next, division. So division, you multiply top and bottom, numerator, denominator, by complex conjugate of denominator, not of both. So let me give you an example of that. 2 plus I divided by, I'll use these same ones, 3 minus I. So to divide, you actually multiply the top and the bottom by 3 plus I. That's the complex conjugate. You just change the imaginary part sign. Change the imaginary part sign. Do not change the real part. Okay, and then I have to multiply the top by 3 plus I as well. Otherwise, I'm changing the number itself. Okay, the denominator, I will just take 3 times 3 is 9. Now you multiply out, just like I did in multiplication. Minus 3i plus 3i, which go away, and minus I squared. So the denominator just gives you 10. Remember, this is from -1, so it's minus 1 or plus 1. Now multiply the top out. 6, outer is plus 2i, inner is plus 3i, and last is plus I squared, which is minus 1. So this is 5 minus, plus 5i. And you could have simplified this a little bit if you wanted to, because both the top and the bottom have a 5 in it. So it could be 1 plus I over 2. Okay, that's division. The last thing for complex numbers, other than addition, multiplication, division, addition, subtraction, multiplication, division, is just doing the square root of a radical of negative numbers. So if you have, for example, the radical of -7, that is simply I radical 7. Or if I have the radical of -4, is simply I times 2, which is 2I, like so. Okay, so that's it for complex numbers. Next is solving quadratics. We did a number of ways of doing these. I'm going to just walk through a couple of them. One is by factoring, and the other one I'll do by completing the square. Let me just do a factoring example first, though. So factoring, you need to factor first. So let's say we had 4x squared minus 11x plus 6 equals 0. Now, I know I need to solve this because it says equals. That does not mean, that means solve, not just factor. Okay, so I can factor this out. This is in fact the same one I had before, so I have to know that this is -8 and -3. 24 gives you -8, -3, and I can factor a 2x out of the first, or 4x out of the first part, and a -3 out of the second part. And notice again, these have to be the same. And that gives me 4x minus 3, x minus 2 equals 0. That's another good example of factoring trinomials. And I should check this as well by multiplying out to see that I get this. Now, the solving part. Take each of these parts, and some of these you could probably just see, and set them to 0, because something times 0 is 0. This gives you add 3 divided by 4, or x equals 3/4, and this one gives you x equals 2. That's factoring, solving by factoring. Second is, we'll do, maybe a moment, write that down. Feel free to pause. And now we're going to do solving by completing the square, which is the one I think people have the most problem with. So number 2, completing square. And I'll write it as x squared minus 4x plus 5 equals, yeah, it's fine, equals 0. Actually, that's factorable. There we go. Plus 7 equals 0. Okay, so what are my steps for completing the square? Put constant on right. I'll do that here. Just subtract 7. Divide middle term, the b, by 2 and square. And add to both sides. So let me do that here. What that means is I take the middle term, which is negative 4. I divide by 2, and I square it. That's negative 2 squared is 4. And now I add that to both sides of the original equation. X squared minus 4x plus 4 equals negative 7 plus 4. Okay, now write, W-R-I-T, write, R-I-G-H-T, side as perfect square. So this I know from here, this is negative 2, is simply x minus 2 squared. Use this term right here. Not it squared. You can check it, by the way, if you want as well. X minus 2 times x minus 2 is definitely that. And on the left side here, on the right side rather, I have, when I say right side, I got a little wrapped up there. It's obviously the left side. Write the left side as the perfect square. Okay, and now, finally, extract square. So that means take the radical of both sides, and you get x minus 2 equals plus or minus, that's key, you get two solutions, radical negative 3. Extract square, and then finally solve for x. So add 2. So x equals 2 plus or minus radical negative 3, which I can also write as 2 plus or minus I radical 3. There we go. That's completing the square. If you want more examples, please write those down. That's actually the trickiest part of the solving quadratics. And especially knowing your left from your right, that's obviously really tricky. Okay, now the last one I'm going to give you is the quadratic formula, which I'm just going to give you it to you. And for a general trinomial, ax squared plus bx plus c equals 0, and the solution is negative b plus or minus radical b squared minus 4 times a times c all over 2 times a. Make sure you write that down. It's pretty mechanical to use, but people do forget it. Okay, that's solving quadratics. Next skill is graphing polynomials. Okay, there's two steps to graphing polynomials. One is getting the end behavior, and then using the roots and multiplicity of those roots to sketch. Okay, we'll start with the end behavior. There are 4 different end behaviors for polynomials. There is what I call up and up, down and down, down to up, and up to down. The end behavior is determined by the leading term after you multiply. And you don't have to multiply fully out, you just have to multiply to get the leading term. So for example, if I have x minus 2, x minus 3 cubed, the leading term is x times x cubed, or x to the 4th. If it is not multiplied it out, you just use the leading term. Now, what are these 4 end behaviors? Where do they come from in terms of the leading coefficient? This first one here will be things like x squared, or x to the 4th, even powers, x to the 6th, and positive up front. This is simply a reflection of that, so it'll be negative. Negative x squared, negative x to the 4th, negative x to the 6th. Now you come down here, these are odd powers of leading coefficient, like x cubed, or x to the 5th, or x to the 7th. And this is the reflection of that. Negative x cubed, negative x to the fifth, and negative x to the seventh. Okay, so make sure you've got a picture of those four end behaviors and know how to use them. I'll do an example in a moment to show you how this works. Now we have to do the roots and the multiplicity, and then sketch. So the roots and the multiplicity, the roots are simply, roots come from fully factored form. So like, for example, x minus 2, x plus 4 squared, x plus 8 squared. Let's say that. So my roots are 2, negative 4, and negative 8. Not positive 4, positive 8, and negative 2. They're the things that make them 0. Okay, and the multiplicity is this right here. In this case, 1. Multiplicity means the number of times the root is repeated. Root repetition. Again, not the 8, not the 4, not the 2, the power. And if the root repetition is even, the sketch, the graph, bounces off the axis, the x-axis. Make sure you have this down because this is the most common error, to mix these two up. And odd goes through the x-axis. Okay, so let me give you an example of that with this exact example. First of all, you do the end behavior. The end behavior of this is x times x squared times x squared, or x to the fifth, which means down to up. Then you plot your roots. My roots are at 2, at negative 4, and at negative 8. Those are your first two steps. Find the end behavior, plot it with just little dashes. Find the roots, and now use the multiplicity to sketch. So as you hit negative 8, it is squared, so it bounces off. Then you go back to negative 4, which is my next root, and it is squared, so you bounce off. And then finally you go through 2. And that's it. The other thing I would be careful of is if you see something like, let me give you another example. I'm going to erase this. You see another example where you don't just have an x up front, like, or say x squared. Let's say x squared, x minus 3 cubed. This is a root. It's a root at 0. Don't forget that. It's very common to miss that root. And there's another root at 3. So this one, for example, has an end behavior. Let's make it a little different so it doesn't have the same end behavior. X squared, x to the fourth is end behavior of x to the sixth, which means up and up. It has a root at 0, so don't forget that one. It has a root at 3. And it's going to bounce off both. So it goes down to there, bounces, bounces, and goes off like that. And it's a W. Okay, again, just don't forget the root up front, with its x squared or x. Okay, last one is dividing polynomials. We did two kinds of division, long division and synthetic division. I will review both. So long division is, let's say, x cubed minus 7x plus 5 divided by x minus 1. So it's dividing a polynomial by another polynomial. You set that up. I'll just write an example out and I would do the same. Put your divisor out there, and I can't remember what that's called actually. First of all, when you're dividing by something, make sure that you've got every value of x represented. Here you don't. You have x cubed, you're missing x squared. Then you have x, then you have 5. And that'll be true with synthetic division as well. Just put plus 0x squared in there. Then put minus 7x plus 5. Okay, first step is to find the number of x's in x cubed, or in other words, when you multiply out, match the x cubed. So that takes x squared, one less than this. And that'll be true with synthetic division as well. So x squared, now multiply x squared times x minus 1. Multiply. And you get x cubed, x squared times x, and x squared minus 1 times negative 1, which is negative x squared. Finally, subtract, and make sure you subtract both parts of it. Again, the most common error is to not subtract that. So you get 0 minus x squared, which is just plus x squared. And then you drop the 7x minus 7x and repeat. What power up here duplicates x squared? It's just x. So x times x minus 1 is x squared. X times negative 1 is negative x. Again, subtract. Negative 7 plus 1 is negative 6. Drop the 5 and repeat again. Minus 6 minus 6x. Minus 6 times negative 1 is plus 6. Subtract, and you get negative 1. And that's my remainder, which I write up here as minus 1 over x minus 1. And I'm done. You can subtract the whole thing there. Okay, and now I'm going to do that same problem with synthetic division. And hopefully I get the same answer. I'm not going to erase the answer because I'm going to check that I get the same thing. So when you're doing synthetic division, put a little block over here and put the root, not negative 1. Positive 1 is the root. Put the root. That is the number one source of error in synthetic division. Next, put the coefficients and make sure you put a 0 where the x squared was. That's the second most common error. X squared term is 0, just like it was here. Okay. Now drop the 1 straight down. Multiply 1 times 1, by the way, which is what I was just doing here. And I get 1, and then add them. 0 plus 1 is 1. Repeat it. 1 times 1 is 1. Negative 7 plus 1 is negative 6, right there. Multiply that again. Negative 6. Add them, and you get negative 1. There we go. That is the same answer as that, but we have to convert it back. This is the remainder, the last term, and again, a very common error to make that the constant term, for example. The next one to the left is the constant. Then this is the x term. This is the x squared term. So therefore we get x squared plus 1x minus 6 minus 1 over the x minus 1. And you get exactly the same answer. As you should. Okay, if you want to write some more examples in there, I would do so throughout this whole thing. Hope that is helpful, and good luck.